Uh, Time 9:30. Very good morning, and those who are attending in other time zone, good afternoon, good evening, as it applicable to your area. So we are in the 6th international conference on EAIT, emerging applications of IT, information technology, and today we are on the third day, 27th of February. We have various sessions that highlights with a lot of insights on this EA emerging applications in this area. It's a very developing area, and a lot of research work going on, a lot of applications coming up, and especially under this COVID-19 situations where the entire context has changed. And we have the privilege of meeting and interacting with eminent speakers. For today, we have invited Dr. Professor Anirban Mukhopadhyay as a keynote speaker for this session. Just let me give you a very small, brief introductions and his profile. Dr. Professor Anirban Mukhopadhyay, he is currently the head and the professor in Department of Computer Science and Engineering, University of Kolani in Kolani, West Bengal. He did his bachelor's from NIT Durgapur in the year 2002, and then completed his master's as well as PhD from Jadavpur University. He is the recipient of a gold medal and Amitabh De Memorial Gold Medal from Jadavpur University in 2004 as the first, ranking first class first in Masters in Engineering. He also received Erasmus Mundus Fellowship in 2009 to carry out postdoctoral research at University of Heidelberg in Germany and with German Cancer Research Center in the year 2009 and 10. Dr. Mukhopadhyay also visited ICS Laboratory University in Nice, Sofia in Nice, France in 2011 as a visiting professor, and University of Göttingen, Germany as a visiting scientist with DAAD scholarship in 2013. He was also a visiting researcher in Colorado State University, Fort Collins, USA, with Fulbright Nehru Academic and Professional Excellence Fellowship during 17-18. He has received Institute of Engineers India Young Engineers Award in the year 2013-14 in computer science computer engineering discipline, and Indian National Academy of Engineering Young Engineers Award in 2014. He has co-authored one book and over 150 research papers. I think it stands 186, and the numbers is still counting. Papers in various international journals and conference. Dr. Mukhopadhyay attended many national and international conferences in India and abroad. He's a senior member of IEEE, a member of ACM and International Association of Engineers, Hong Kong. Dr. Mukhopadhyay himself is an active member of Board of Reviewers in various international journals and conferences. His research interests include soft and evolutionary computing, data mining, multi-objective optimization, pattern recognitions, bioinformatics, and optical network. We are all eager to hear from Dr. Mukhopadhyay. So it's your stage, sir.
Thank you, sir, for a nice introduction. It's my privilege to get invited in this conference, EAIT 2020, which is actually being taking place online with collaboration with my department and the CSI. So it's really a privilege. So today I will talk about some of my research activities, particularly in the domain of clustering, data mining and clustering and its application. Let me share my screen. So I hope my screen is visible.
Yeah.
Yeah,
Yes.
thank you. So the title of my talk today is multi-objective genetic algorithms for data clustering. So here I will discuss that how we actually applied multi-objective genetic algorithms for the well-known data clustering problem, and I will try to discuss some of the applications that we did. So you know that clustering is a popular data mining technique where the responsibility of any clustering algorithm is to, given a data set, we have to group similar objects into homogeneous partitions based on some similarity or dissimilarity metric, so that uh, the objects or the points in a particular partition or a cluster are similar to each other. And when we take two different objects from two different clusters, they should be as dissimilar as possible. So for example, given a data set like this is a 2D data set, two-dimensional data sets. But in reality, it can be of any dimension, any number of dimensions or any number of features can be there. So given this kind of data set, the job of clustering algorithm is to group the points into homogeneous clusters. And particularly, there are some centroid-based clustering algorithm where the job is basically to identify some representative points in a cluster, which is basically the we call the cluster centroids like this. So you know that there is a very popular clustering algorithm for its probably over 70 years old now, or not at least 70 years, or at least 60 years old now, that K-means clustering algorithm. Probably all of you know that. I'll just quickly discuss the steps of K-means clustering. So here the job of the K-means clustering actually works like this, that we choose K random points as the initial cluster centers from the given data set. We just pick up K number of random points. K is an user input. K random points as the initial cluster centers. Then we assign each object or each point in the data set to the cluster centers which is nearest to it. So this way, each data point in the data set is assigned a cluster level by assigning them to the nearest cluster center. Then once this assignment is done, in the third step, we recompute the cluster centers by just taking the mean of each cluster. Just taking the average of the coordinate-wise average or mean of each cluster, we just update the cluster centers. So this step 2 and step 3 actually continues. So we again go back to step 2 and again reassign the points to the nearest cluster centers. Again comes to the step 3 to recompute the cluster centers again. So these continue until the algorithm converges. That means in two successive iterations, there is no change in the cluster centers. So this way, the output of the algorithm is K number of cluster centers or K clusters. So this is a very basic algorithm that this K-means algorithm, but very popular algorithm because of its scalability. This is scalable in nature. That means even for very big data sets, the K-means algorithm works fairly quickly. So the K-means algorithm actually optimizes a criteria which is known as the cluster variance, we say. So let's say that Vi is the ith cluster center and Xj the jth data point. Now this d square Vi Xj is basically the distance, the squared distance between the cluster center Vi and a data point Xj. So when so the overall criteria is like this, that we repeat for each cluster. So I equal to 1 to K means we repeat for each cluster. Then we find which points belong to that cluster. That means which points have been assigned to this cluster, that Xj belonging to Ci. And for those points, we calculate the distance of those points from the center of that cluster. So it's something like this. So you see that suppose this is the ith cluster. So we find this is the cluster center. We find the distance of each point of that cluster from the cluster center, like this. And we then sum up these distances. And this is repeated for all the clusters. And we then find the overall sum. And this overall sum is basically what we call the J value. So it actually denotes the cluster variance. And the K-means algorithm actually tries to minimize this cluster variance to get the compact clusters, because it wants that the points within a cluster should be as close as possible to the cluster center. So it gives the compact clusters. So I will just briefly discuss how the k-means actually work with a visual representation, so that it will be easy to understand. So suppose given this data set, we have to suppose we are given that k equal to 3. That is, we have to divide this data set into k clusters. So as per the first step of k-means, we randomly pick up k number of points as the initial cluster center. Suppose, so in this case, we pick up 3 random points as the initial cluster centers. So suppose these are the 3 random points. So then the next step is to assign each data point to its nearest cluster center. So we assign each point to its nearest cluster center, so that all these points will be assigned to this cluster center because this is the nearest. Then all these points will be assigned to this cluster center, and all these points will be assigned to this cluster center. So this is the initial clustering. Then once this initial clustering is done, we recompute the cluster center, so that we take the mean of these points to update this cluster center. We take the mean of these points to update this cluster center, and mean of these points to update the third cluster center. So the next step will be like this. So these cluster centers are recomputed, and they will be moving to this. These red points will be the new cluster centers. Okay. So again, we go back to step 2 and again reassign the data points to the nearest cluster center. Again, recompute the cluster centers, and this goes on until in 2 successive iterations there is no change in the cluster centers. And this is the final clustering that we get. So this is how the k-means clustering works. So k-means clustering is a very popular approach still now. If we just search the top 10 data mining algorithms, you will definitely find k-means as one of them, even it is more than 60 years old algorithm. But there are some serious limitations of k-means algorithm. Nevertheless, there are some limitations of k-means algorithm. So one limitation is that as you can see that we start from random initialization. That means we pick up k number of random initial points, random points as the initial cluster center. So depending on the choice of the initial cluster centers, sometimes the k-means algorithm gets stuck at some local optima. That means that J value, that cluster variance value that we get in a particular run, that may not be a globally minimum value of J. So it depends on the initial choice of the cluster center. So for the same data set, for the same number of clusters, if you run k-means algorithm multiple times, you may get different clustering solution. So each of them is actually a probable local optimum of the J value. So this problem can be solved. Many people have solved this using genetic algorithm, because which is genetic algorithm is a randomized search techniques and which is known to give at least near global optimal result. So this is very robust algorithm which tries to give the near global optimal solution. So when we just punch k-means into genetic algorithm, this particular problem is solved actually, that getting stuck into local optima by in a particular run. So if we just punch into genetic algorithm, k-means updation is done using the genetic algorithm, then this local optimum problem is more or less removed. Now, the second limitation of k-means algorithm is that it optimizes a single objective function. single objective function J, or the cluster variance. But the problem is that a single objective function may not be capable enough to capture the different characteristics of a data set, because there are a lot of different types of data available in reality, and a single objective function J, if we minimize that, it does not guarantee to give you a good clustering solution. And it is generally found that there are other clustering criteria. If we just optimize those criteria, they work for some data sets very well, where J does not perform well. But K-means algorithm only optimizes J, so it is not capable of capturing different characteristics of all type of data set. It may work for some data set very well, but for some data set it does not work nicely. So here, actually, we proposed a multi-objective clustering approach, where this multi-objective clustering algorithm is based on multi-objective genetic algorithm, which can optimize more than one clustering criteria, which are called as cluster validity indices, simultaneously. They can optimize more than one clustering criteria simultaneously, so that they can give you more robust result, in the sense that they will give more or less good result for almost all kind of data sets, which where the K-means fails. So why multi-objective clustering? Because simultaneous optimization of multiple objectives may lead to higher quality solution. As we are optimizing multiple objective function, multiple cluster validity indices simultaneously, so they are expected to lead to higher quality solution and also improved robustness towards different data properties. So it becomes indifferent to the different data properties as we are optimizing multiple criteria simultaneously. So let me just quickly go through some basic definition of multi-objective optimization. Then I will just discuss that how we applied this into multi-objective clustering. So you see that in many real-world problems, we have to simultaneously optimize two or more objective functions, which are often competitive or contradictory in nature. For example, suppose I want to find an optimal path from Kolkata to Delhi. We may want to optimize many things. Say we want to minimize the distance, we want to minimize the cost, or we want to minimize the time. So there are different objective functions, and many times these objective functions are contradictory in nature. That means if we want to minimize the distance, the time, or if we want to minimize the cost, the time may increase. And whereas if we want to minimize the time, the cost might increase. Because if we want to minimize the cost, we have to travel by train, so it will take more time. And if we want to minimize the time, we have to travel by plane, it will take more cost. So they are often contradictory in nature. So finding a single best solution in this case is very difficult. So it is most of the cases it is not possible to find a single solution which will give you the best time and as well as cost. So actually the more practical case is that you will get a set of trade-off solutions, which I cannot say that this solution is better than the other one, but some solutions are better in time, some solutions are better in cost. So these will be called as trade-off or some compromised solution, a set of solutions you will get. So optimizing each criterion separately. So when you have multiple objective functions, if we want to optimize one of the objective functions separately, keeping the other as constant, it may lead to good value to the objective function you are optimizing, but it may give you some unacceptably bad value for the other objective function. So that is not a solution. You just cannot optimize a single objective function leaving the others. You have to optimize all the objective functions you have simultaneously. So this is a formal definition of any multi-objective optimization problem. So here we have to find the vector of decision variables. So that is our solution. So decision variables means the parameters of the particular problem, which will satisfy some constraints, some inequality constraints and some equality constraints, and it will optimize some vector function. So this is the difference with the single objective optimization and the multi-objective optimization. So in a single objective optimization, all three are fine. These are same, because in that case also we are trying to find some solution satisfying some constraint and optimizes a single function. That is for single objective case. But for multi-objective case, we have to optimize a vector function or a set of functions, set of k number of objective functions simultaneously. So this is the what we have, the multi-objective optimization. Now, in terms of multi-objective optimization, one important property that we must discuss is the non-domination or Pareto optimality. Now you see that major difference in single objective optimization and multi-objective optimization is the comparison of two solutions. So in a single objective case, it is easy to compare given two solutions. We just compute their objective function value, and the better objective function value means that solution is a better one. So that is for single objective case. It is easy to compare two solutions. But when we have multiple objective functions, it may not be easy to compare two solutions, because it may give you give rise to many cases. I just give you some examples. So suppose we are dealing with a minimization problem. That means all the objectives. So suppose we have three objective functions, f1, f2, f3, and all of them are of minimization type. That means we want to minimize all of them. Smaller value means a better solution, better objective value. So now if we compare two solutions, solution A and solution B for a particular problem, and they are giving these objective function values for these three objective functions, these are solution A is giving value for f1 is 2, f2 is 4, f3 is 3, and solution B similarly it is giving value 2 for f1, value 7 for f2, and value 6 for f3. Now you see that for f1 both the solutions are giving the same objective function value. For f2, solution A is definitely better than solution B, because this is a minimization problem, so 4 is better than 7. And for f3 also, solution A is giving a better value than solution A is giving the better value than solution B. So in this case, what we are saying that out of the three objective function, solution A is giving better value than solution B in two of them, and solution A and solution B have the same value for f1. So it is clearly saying that solution A with respect to these three objective functions, solution A is a better solution. So we say in this case that the solution A dominates solution B. So this domination is a particular technical term here we use, that solution A dominates solution B. Now, on the other hand, in this case, in this particular case, you see that for f1 and f2, again, both the solutions are same, but for f3, solution B is better. So in this case, solution B dominates solution A. But in the third case, you see that they are same for f1, but they are for f2 A is better and for f3 B is better. So in this case, we cannot say that solution A dominates solution B or solution B dominates solution A. We cannot say like that. So we say that solution A and solution B are non-dominating to each other. So this non-domination is important. So this is the formal definition of domination relationship, that let A and B are two solutions, So for a minimization problem, a solution A is said to dominate solution B if and only if for all objective functions, solution A has a smaller or equal value than solution B, smaller or equal value than solution B, and there must exist at least one objective function where solution A is strictly smaller than solution B. So for all the objective functions, solution A must be better or equal, and there must be at least one objective function where solution A is strictly better. So in that case, I will say that solution A dominates solution B. Now, this non-domination relationship is very important to compare the solutions in a multi-objective search space. So the set of solutions that are not dominated by any solution over the complete search space. So in the given search space where a lot of solutions exist, I will just try to pick up those solutions as the best solutions which are not dominated by any other solution in the search space. And this non-dominated solution set is known as the Pareto optimal solutions. So this Pareto optimality concept is very prominent in multi-objective optimization. So the goal of any multi-objective optimization problem is to just find out the Pareto optimal solutions. That is those solutions which are not dominated by any other solution in the search space. So I just give you one example. Say, suppose this is my search space. Two objective functions are there, F1 and F2, two objective function, and we just assume that both are minimization objective functions. So, so among all the solutions, if you look into these solutions, you will see that these solutions are not dominated by any other solution in the search space. But if you just look any other solution, for example, if you just say solution X7, it has F1 value of these and F2 value of these, but you will see that there are some better solution exist which dominates X7. For example, X3 dominates X7 because X3 has a better value of F1 and F2 than X7. So X3 actually dominates X7. So X7 cannot come in the non-dominated set. But these X1 to X6, these solutions are the non-dominated set of solutions. So if this is the complete search space, then I will say that this is the Pareto optimal set of solutions. So the goal is here to find out the Pareto optimal set of solutions. So this is the classical single objective genetic algorithm. So here the problem is to encode a possible solution of the problem in a form of a chromosome. So probably many of you are already acquainted with the genetic algorithm. So here we just try to encode the solutions, possible solutions of the problem in a strings or the chromosomes. And we just start with this set of randomly generated initial solutions, initial set of chromosomes. Then we compute their, we just decode the chromosomes to get an individual, then evaluate the fitness or objective function value of the solutions, then perform some genetic operations like selection, crossover, and mutation to obtain the next generation set of solutions. So this is the loop of the genetic algorithm that continues. So you know that the genetic algorithm is inspired by the Darwin's evolution principle. So over the iterations, the set of solutions gets improved through the selection, crossover, and mutation. And these steps are repeated until some stopping criterion is made. And for a single objective case, in the last generation, the best solution that we get is the final solution that we report for a particular problem. And elitism may be incorporated. Elitism means that we just keep track of the best solutions so that they are not lost over the iterations. And the best fit chromosome of the last generation population is considered as the final solution. So this is the classical genetic algorithm for a single objective optimization problem. Now, when we try to use this genetic algorithm for a multi-objective case, the major difference for a single objective and multi-objective case comes in the selection process. Process means that we just select some of the solutions from the previous generation to the next generation based on based on their fitness value. That means better fit solutions have better chance to be selected. But here the selection problem for multi-objective case is actually difficult for multi-objective case because the comparison of the solutions is difficult. For single objective case, when we compare, when there is a competition between two solutions, we just simply pick up the best solution in terms of the objective function. But for multi-objective case, it's not so straightforward. So I'll just quickly just discuss one of the multi-objective, very popular multi-objective algorithm that is called non-dominant sorting genetic algorithm 2. It was proposed by Professor Kalyanmoy Dev. He was in IIT Kanpur at that time, but he has now moved to US. So there are three primary concepts, that is non-dominated sorting, diversity maintenance through crowding distance, and elitism by preserving the non-dominated solution. It's I don't have enough time to just cover all of them in detail, so I will just directly go to the genetic algorithm loop to see that here again we just start with a population of solutions, usually randomly generated. Then we evaluate the fitness values, objective function values of all those solutions, and then we perform the non-dominated sorting. So non-dominated sorting is nothing but we just suppose these are the set of solutions in the population. Then we find that which solutions of these population are the non-dominated, which are non-dominated, not dominated by any of the solutions. So this solution, this red line, which falls on this red line, these are the non-dominated solutions of this complete set of solutions. So these are called the rank 1 solutions. Okay? These are called the rank 1 solutions. Now we temporarily remove the rank 1 solutions, and from the rest of the solution again we find out which solutions are not dominated. So these green line solutions, these are not dominated from the rest of the solution set. So these are called the rank 2 solutions. So this way we go on rank 1, rank 2, rank 3, rank 4, etc. until all the solutions get some rank. Okay? So this way we classify, basically we classify the set of solutions that we have in our population in different ranks, so that it becomes easier to compare when you compare two solutions from two different ranks. So definitely I will prefer rank 1 solutions over rank 3 solutions, and so on. So once this is called the non-dominated sorting. So we just sort the solutions according to their non-domination status. So once this is done, then we perform the selection. This is called the crowded binary tournament selection. Here what we do is that, say this is a tournament selection, so we randomly pick up two solutions. So if these two solutions are coming from two different ranks, like this one, S1 is coming from rank 2 and S2 is say coming from rank 5. So it is easy to compare because we know that S1 is a better solution than S2. And we select S1 to put in the mating pool. But the problem comes when they come from the same rank. They are coming from the same rank. Then we use a crowding distance criteria to select the solution which is not crowded by many other solutions in that rank. Because if we just lose this solution, we may lose that part of the Pareto front. So that's why we prefer the less crowded solution from a particular rank. So this is called the crowded binary tournament selection, and this is used for creating the mating pool. And then we perform the crossover and mutation. Then this is for the elitism purpose. We just combine this parent population and the child population into one single population, and then again perform the non-domination sorting with the combined solution. So this is the elitism part basically, and then from the combined solution, again, we pick up the top few solutions for the next generation. And this is the loop for the multi-objective NSGA2 algorithm. So this goes on, and finally we get a set of Pareto optimal or at least near Pareto optimal solutions. So here the final output will be the rank 1 solutions, okay, in the final generation that we get. These are the final output. Now, how we use this NSGA2 for multi-objective clustering? So the first step is to the chromosome representation of any clustering solution. So a clustering solution is represented by a set of cluster centers that we have already seen for K-means problem. So output is the set of K number of cluster centers. And if we are dealing with a D-dimensional data set, so each cluster center has a D number of coordinates, right? D number of coordinate values. So if there are K number of cluster centers, so we can just represent them as a string of size D into K, where the first D values represent the first cluster center, the second D values represent the second cluster center, and so on, and the kth D values represent the kth cluster center. So this is a chromosome representation or string representation of the clustering solution that we have used. So just for example, if D equal to 2 and K equal to 3, D number of dimensions and K number of cluster centers. So if you have a chromosome like this, it actually represents 3 cluster centers. So first 2 will represent the first cluster center, the second 2 will represent the second cluster center, and the last 2 represent the third cluster center. So this way we can encode and decode our clustering solutions. So we initialize the population by picking up random points from the data set, and if there are p number of initial solutions in the data set, so that basically represent the p different clustering solutions randomly picked up or randomly built from the data set. So that is the initial starting point, initial population of solutions. The next step is to compute the fitness values. So here we are using multiple objective functions. So the phase 1 is to extract the cluster centers encoded in the chromosome and assign the points to the nearest center. So here we perform a single step of K-means clustering. So once that is assigned, so then we recompute the cluster centers by cluster means and update the chromosome with the new cluster centers. And then we compute the fitness value. So here it is different. Here we are computing 2 different objective function values, unlike K-means, which work only with the J values, that cluster variance or cluster compactness. Here we additionally use another objective function, that is cluster separation, which actually computes the distance between each pair of cluster centers and sum up those distances. So here we have to minimize the first objective function and we have to maximize the second objective function, because we want more compact clusters so that the cluster variance should be small, and we want well separated clusters. So that's why the second objective function has to be maximized. Okay, and so then we perform, this is just an example, I just skipping this particular step. So then we perform the selection, that is the crowded binary tournament selection that we already discussed for use for NSGA2. Then the crossover, we used a single point crossover. So crossover is nothing but just exchange of information between 2 different solutions. So we use a single point crossover, and then mutation is basically as the cluster coordinate values are real values. So we use the floating point mutation by just moving one of the cluster centers a little bit. So mutation is basically a little perturbation of the cluster centers. So these are the 3 genetic operations that we perform. And this way the NSGA2 loop is loop works, and in the final solution, in the final generation, we just receive the rank 1 solutions. As I said, that it is very unlikely to get a single solution. single best solution that gives the best value for both the objective functions. But more practical case is that we obtain a set of trade-off solutions. So I just give you the example. So a set of trade-off solutions like this. So suppose these are the final set of solutions, seven clustering solutions that we get. One objective function is J value, another objective function is the reciprocal of separation value. So both are minimization. So maximization of separation means minimization of the reciprocal. Okay. So once we get a solution, but our final job is to get a single solution out of that, because finally we want to receive a single clustering solution. So for that, what we did, as all the solutions are equally important as per the non-domination status, none of the solution is better than the other one. So each of them has some characteristics of the clustering structure of the dataset. So therefore we decided to just have a consensus among these solutions so that we get the final solution. So what we did is like this. This is just an example. Suppose we have 10 data points, okay, that we are going to cluster, and these are the 7 clustering solutions that we have received in the final generation, the rank 1 solutions. So these solutions look like this. So you see that solution 1 says that point x1 goes to cluster 1, point x2 goes to cluster 1, point x3 also goes to cluster 1, point x4 goes to cluster 2, x5 goes to cluster 2, and so on. Similarly, S2 also has a clustering solution like this, and so on. Now, what we did, we just perform a majority voting. Majority voting in the sense that we just see that, okay, out of 7 solutions, if x1, when we consider a particular point to decide its final clustering level, we just see that whether it is more than 4 solutions are saying that saying for a particular or voting for a particular cluster level. So here see that for x1, all the 7 solutions are saying that it must go to cluster 1. So there is nothing to decide here, so it will go to cluster 1 definitely. But for solution x2, you see that for point x2, 2 solutions are saying that it should go to cluster 1. 4 solutions are saying that it should go to cluster 2, and 1 solution is saying that it should go to cluster 3. But no particular cluster level is there for more than 4 solutions here. More than 4 solutions. So we cannot immediately assign a cluster level for this point. So this way we perform the voting, and we find out for the majority cases, we just find out the final cluster level. But for some data points, we cannot immediately find the final level of that points, final clustering level of these points. So then what we did, for the points which are already assigned a cluster level by majority voting, we use these points for the training purpose. We train a particular classifier. Suppose support vector machine classifier that we used here. So we train the classifier because these points are already assigned the class levels. So we can use these points as the training set. And these points are used to train the classifier. Now, once this is trained, then we can predict the class level of the rest of the point, that is x2, x5, and x7, because we are still unsure of their class level. So we can use this trained classifier to predict their class level. So then we combine this training set and test set to get the final cluster. So this way, from the set of Pareto optimal clustering solutions, we get a final cluster. Okay. So this was our proposed approach. This was published in originally published in IEEE Transactions on Evolutionary Computation. So that's a very prestigious journal, but we had to work for almost 3 years for this particular because it was revised 4 times. Okay, so you have to be very patient. Okay. Anyway, so I think I have another 10 minutes, so I will quickly discuss two particular applications of it. We first applied it for image segmentation or image clustering problem for some satellite images. We used two images. So this is a image for the Kolkata image. It was taken from IRS, Indian remote sensing satellite image. You see that this is an old Kolkata image. Okay, so now it has changed in many ways. Anyway, so this is the river Ganges that cuts through the image. And this is the major city area, okay, the Esplanade and the major parts of the city. You see that this is the Salt Lake areas. A lot of open spaces are there, and these are the fisheries just beside that the EM bypass nowadays. So, and these two strips actually represent the airport runways of the Damdam airport. Now, this image, we applied our method to cluster this image, and this is the image, the same image clustered using the fuzzy image clustering. So you see that it works usually well, but it has a mixture. It has confused between the river and the city area. They have been put in the same class. So by the fuzzy image clustering. But when we apply our method, you see that it is clearly distinguished from the river and the city area. They are put in different classes. And this Damdam airport lines, the airstrips or the runways are clearly visible. The Salt Lake has a lot of open space, as you can see, because this is a very old image. So in 90s, this image was taken. And another important point is that due to the spectral properties, the river water and the pond water has different spectral properties. So they are put in the two different clusters. This is the Bombay image. So this is the Arabian Sea, and this is the major city areas of Bombay. And this is the Bombay dockyards, some islands, including the Elephant Island and other. So this is the fuzzy image clustering. And here also that this sea area have been classified into 3 different clusters. So that is actually wrong. Whereas in our case, it is clearly classified into 2. So that this part is one has a particular spectral property, and this part of the sea has another particular property. And there is a lot of confusion between the habitation and the concrete. So because they are likely to have confusion regions, because the habitation, I mean that the buildings and the concrete regions, so they must have some overlap, and that is clearly visible from this image. And this is some numeric results that we did for the comparison. So based on the I index value, so this is a particular clustering index which was not optimized. Remember, this was not optimized by our algorithm, but this is as a third index we just compared. And for the both the images, our method, that is MOGA SVM, multi-objective genetic algorithm with support vector machine, has a better, giving better value, a larger value of I index. Another application was in bioinformatics. Maybe I just take 5 minutes and then complete. So in bioinformatics, what happens, you see that this is called the central dogma of molecular biology, which says that the genes of our chromosomes are transcribed into RNAs, and these RNAs are finally translated into proteins. So genes are the hereditary units. So these are the programs, basically. Genes are the programs, but they cannot function themselves. So until they are converted into proteins. So these are the functional units. All the works in a cell, all the functions in a cell are actually done by the proteins. Now, unless the genes are converted into proteins, they cannot function. So once this gene is converted into RNA, they are called, we call the gene is expressed. Okay, and this expression value can be measured. So there are some biological experiments. So there's a technology called microarray technology, which can measure the expression level of different genes. So a microarray data looks like this. So here, this is basically a matrix where the rows represent the several different genes and the columns represent the different experimental conditions or maybe different patients and so on. So you see that these values actually represent the expression value. For example, this value represent the expression value of gene 1 under condition 1. This value represent the expression value of gene 1 under condition 2. So these negative values are coming because we have normalized this data set. And these values are also represented in color coding, like the higher value represent the more reddish and lower value represent more greenish color. And the middle level value, which are close to 0, are represented by the blackish color. So this is an example of a microarray data set. And here our job is to basically cluster the gene according to their expression pattern. So the genes we have similar expression pattern are put in the same group or same cluster. So how it works, so we applied our algorithm. So this data set also can be represented by a cluster profile plot like this. It is easy to follow. You see that for a particular gene, we can plot a line like this. So just putting the condition, the expression value. So for condition 1, it has an expression value. Condition 2 have another expression value. Then condition 3, it increased expression value. Condition 4 further increased. Then in next condition, it decreases its expression value and so on. So for each gene, you can have a line like this. So these are all the gene profiles. Profile lines. Now this is used for visualization. So these are the 5 real life data sets that we used for the clustering purpose. So we have to cluster the genes for this data set. These are the sizes of the data sets. So these are the original number of genes, and then after some pre-processing, we have removed some of the genes and come with this. And these are the number of conditions or number of time points. So over the different times, this expression value have been measured. And these are the numeric result in terms of the silhouette index. So this is another clustering index which we are not optimizing, but it is being used for computing the final, the quality of the final solution. And larger value, I mean the closer to 1 means a better solution. And we just compared with many other algorithms like FCM, single objective case, average linkage. This is a hierarchical clustering, then SOM, self-organizing map clustering, etc. And you see that for all the cases, for all the 5 data sets, our method, that is the first column, has the highest value. Most of the cases, I mean that all the cases have the highest value of the silhouette index. And these are some visualization. You see that this is the clustered microarray in the color coding for the yeast sporulation data. You see that if we look into one particular cluster, say suppose this cluster, you see that all the genes, so each row actually represents a gene. So all the genes have very similar expression pattern. Initially, they have very low expression pattern. Over the time, they are increasing. And at the end, they have very high expression pattern. So this is 1, 2, 3, 4, the cluster number 4. So this is the corresponding cluster profile plots. Okay. You can, that from the profile plots also you can see that all the genes initially have very low expression pattern, then it increases a little at the middle, and then it has very high expression pattern. So this is the trend for all the genes of that cluster. So for each cluster, the genes have very similar expression pattern. Okay. So this way, we can cluster the genes. So this is very important, but why we need to cluster the genes? Because we can just, for a particular cluster, maybe if we already know the functionalities of some genes, then we can gauge the functionalities of the other genes of that same cluster. And this has many applications actually in bioinformatics. So for the other data sets also, these are the visualization. This is a very interesting, you see that each cell cycle data, it is just like a sine curve or cost curve. So it's decreases, then increases, again decreases, then increases, and so on. So you can also visualize it from the myQuery or the heat map plot. So this is called a heat map plot. So initially small expression, then again it increases, then again decreases, it becomes green, again becomes red, so increases, again becomes green, and so on. And these are for the other data sets. I'm just passing it. And these are some biological significance plots. So we can compute the p-values of the significant gene ontology terms. So this is some biological relevance study. And our algorithm actually gives a better p-values. That means more biologically coherent clusters that we get from the output of our algorithm. So these are the two different applications of multi-objective clustering we did. And okay, we should conclude now. I think the time is almost over. So our major contribution is to apply this multi-objective genetic algorithm in clustering for the probably the our group was one of the two groups working on this particular problem over the world and then we applied this clustering problem and its variants in many different applications, both in data mining and bioinformatics and also other fields. And we had written a book in 2011 on this particular problem that was published from Springer. And these are the some of our works, some of our publications based on which we have prepared this particular presentation. And that's all. Thank you for your patience. And I'll be happy to answer any question if you have.
Thank you, Anirban. It's a good input. Any queries or any questions? Can anybody ask?
Actually, I am Devashish Chakraborty.
Yes.
Yeah.
Dr. Animar Mukhopadhyay, it is nice presentations actually. Thank you for that. So just I am having a one just query. Yes. So during that is satellite image you are showing that you have shown that is you have applied in infrared images. So whether this technique can be useful for the multispectral images also?
No, actually we have used four band actually.
Okay. That's all actually, yes.
I just skipped that part actually.
Achha.
I think, yeah. You see that we have used four bands, blue, green, red, and near.
Yes. That's all actually. That's all. So actually, yes. But you have shown that is black and white image.
That is in the infrared, near infrared band. That just for visualizing the image.
Okay. So that is output is the output of the this is actually output is showing that is a multispectral image output, no?
Yes.
Achha. Okay. Thank you.
Hello, sir. I have one question.
Yes.
Yeah. Your name, please.
My name is Snigdha. I am from Bangalore.
Okay.
Sir, like this genetic algorithm, whatever you have said, can it be applied for like other supervised algorithm, or is it for only clustering like unsupervised algorithm?
No, you see the genetic algorithm is a general tool. I mean, this is just an optimization tool.
Okay.
So if you can use it for unsupervised, it does not matter if it is unsupervised or supervised.
Okay.
If you can form your problem as an optimization problem,
okay,
you can definitely use genetic algorithm. So a lot of applications of genetic algorithm is there for the supervised machine learning problems also.
Okay, actually for my PhD, I am working in the area of like astronomical data analysis.
Okay.
So there like I am using now ADAM or some ADA delta kind of optimizer. So can I try
Yes,
with this
yes,
genetic
yes.
algorithm?
These are very robust. I mean that it can be fit into almost any kind of optimization problem. So that's why
Okay.
they are very popular.
Okay, okay, okay. Thank you, sir. Thank you.
Good morning, sir. This is Dipankar Das.
Yes.
I have a query. Sir, these algorithms, whether it is available in the R software or Python software, or I have to code it in, I have to code it from the scratch. Is any library available?
Yes, if you go into so as I said that multi-objective genetic algorithm and also single objective genetic algorithm, there is a, so it was originally proposed that NSGA2 algorithm was originally proposed by Dr. Kollanmoy Deb. He was in IIT Kanpur then, and he has a lab on that. So that was called, has a very funny name, Kangal. So Kanpur Genetic Algorithm Laboratory. So if you search in Google with Kangal, IIT Kanpur, you will reach that labs page and you will find these libraries. I mean that they have already coded these algorithms there. And but for my case, we actually implemented these algorithms in MATLAB on our own. Okay. And recently, one of my students have built NSGA2, implemented it in Java also. That is available in GitHub. So if you are interested, you can just drop me a mail. I can send you the links. Okay.
Okay. Thank you, sir. Certainly. Thank you.
I think any other questions? If not, then we have to conclude.
May I say something?
Yeah, please.
I'm DP Sinha. Thank you, Professor Dr. Anirban Mukhopadhyay, for this presentation. Surely of interest to all of us joined here. Without going to the mathematical formalisms like these vector functions, inequality construct like that, I may ask a question. Not all the objective functions are known or hitherto explored. So if we include another objective function in a set of 7 or 8 objective functions well known, with say mathematical content determined later, can this model be remodeled or re-ranked to find the strict or best or final solution?
Still now, these works that we have done is the objective functions are known already. That means its mathematical formulation is known to us. So you are saying that you have an objective function, you are not yet sure that what is the mathematical formulation, right?
Absolutely.
Yeah.
Maybe you have mentioned about that the cost, time, etc. Maybe the quality with some mathematical input value will come, and that may have the best solution of the. I think that. I think you understood. Right? Maybe it may come.
I'm not very sure. I have to think about it. It's a very good suggestion, actually. I'm just getting.
Thank you very much. Okay.
From the given data set, so if you want to find its quality, at least you need some value, not so. I mean, it's otherwise it will be difficult to fit into this particular model. Maybe.
No. I'm saying the value is to be value will be given, but that attribute of this one is not yet known. Right.
But objective function value can be computed.
Right. Okay.
Yes. Then you can. So we don't need actually the mathematical the formulation. We need just the value. Okay. If we need, if we have the value, then definitely we can just put the value as the objective function value for that. So we don't need the mathematical formula.
But that may vary from time to time, right?
Yeah, that's fine. That's fine.
Okay, thank you very much.
Thank you very much. Now, I hope we have concluded this. Thank you very much, Professor Anirban Mukhopadhyay, for your good support and this. Now, I think The certificates and other things have been already distributed, na? Any response, Professor Mondal? I hope Anirban has read this.
Mr. Arendlai, sir, kindly note that the certificate we will give Dr. Anirban Mukherjee, but the thing is that the certificate is already signed by Dr. Anirban Mukherjee and myself and others.
Okay, thank you.
We can send him.
No, these whatever supposed to be given the others, the participants, they have already got it. But anyway, now is the tea time. I hope now enjoy the tea. Then again, the next session will start at 11 o'clock, right?
Sir, the certificates will be mailed to us?
I think so. That is why I read.
Certificates will be mailed to each and every session chair, participants, presenter, keynote speaker.
Okay, it will be mailed.
Yeah.
Oh,
Thank you.
Thank you.
Okay, so just to note, the next keynote session will begin from 10:45 a.m.
Okay. So tea time is only for 15 minutes, right?
Yes, sir.
I have already started taking tea.
Okay. Thank you.
Session will remain open.
Thank you, lady.
Thank you.
Those who wish to stay may stay if they want. The session will remain open.
In third day of the international conference EAIT 2020, it is my great pleasure to introduce him to the audience. Sri Sabyasachi Mukhopadhyay is a faculty of business analytics and statistics in Makaut, Government of West Bengal, India. He is a former assistant professor of business analytics at BIMS, Kolkata. He is not only the leader of Facebook Developer Circle, Kolkata, but also the Google developer expert in machine learning and Intel software innovator. He is the visiting faculty at Symbiosis Center for Information Technology, Pune. He is the paper setter, examiner, and moderator of Macaut and SCIT Pune. I welcome Sri Sabyasachi Mukhopadhyay on behalf of Organizing Committee EAIT 2020 for keynote speech.
Thank you very much, Dr. Chakraborty, for your generous introduction. So let me share the screen.
Yeah. Please.
যেটা তোমাকে ম্যাক আউট করতে বলেছিল সেটা তুমি করনি কেন?
Is the screen visible to all of you?
Yeah, it is visible. It is visible.
Okay, just a second. I am trying. Just a second. I'm trying to click on slideshow button, but it is not working. Just a second.
No problem. You take your own time.
Just a second. Just kindly check whether you can notice the changes of slide. Can you see the changes of slides?
Yeah.
Okay,
Now
okay.
Nicely visible.
Okay. Fantastic. So basically, in today's talk, should I start? I guess it's already 10:45, right?
Yeah. Please start. Please.
Okay. Thank you so much. So in generally, what happens whenever we observe certain problems in our society, we have certain tendencies like chalta hai, chalta rahega. Some of us complains, but there are very few number of the solvers. So standing in the scenario of Industry 4.0, you see that across the globe, there are more than 80% people under the bottom of pyramid category, and India, the percentage is more than 96%. So that percentage of the people do not have enough money to pay tax. So you can understand if somebody is suffering from cancer, if somebody is suffering from diabetic retinopathy, how miserable will be their life to bear those expensive treatments. So being a scientist or being a professor or being a physicist or being a physician, whatever may be our profession, it is our social responsibility, if we can contribute from our little knowledge towards the society, if their life becomes much more better from the blessings of science and technology. So this works is a step towards that type of contribution. And first of all, while proceeding towards that particular path, we have to fix up a little bit of mind setup, because you see, we all have across the globe, whatever the people, there are billions of people are there, and everybody has their own intrinsic innovations within them. But in most of the cases, we are unable to find out that is the sad part of scenario. So that is the reason it is very much important that what problem should we solve, to fix up our own philosophy, own mind setup, and then we will proceed towards science, then technology, then production, and finally marketing. So these 5 paths I will try to cover up with this presentation. So basically, as I repeat, first of all philosophy, then science, then technology, then production, and followed by marketing. So let's see. So basically here, for example, we are picking up one particular theme, digital tech in agriculture. Okay, and under that, we will discuss about the resource mapping, problem canvas, solution canvas, and finding plot. And while discussing the digital tech in agriculture, we will map the same problem in case of the healthcare domain to see the possible brainstorming cases. Okay, and then after we complete that, we will go to the corresponding science and technology part. So under the resource mapping, there are, for example, we will discuss about the people and organizations, user and beneficiaries, breakthroughs and risk factors. So basically, if you see the organizations, for example, there are companies, startups, government departments which are relevant to it. We basically, whenever we are nowadays, we belong to the digital world, and we are storing data digitally. So you see, as we are storing data digitally, there will be the data sets and information resources. Ample amount of the opportunities are there. You can download data from GitHub. You can download data from Kaggle to build your own data modeling techniques through deploying several algorithms. But you see, if you are exploring that thing in case of the healthcare domain, now you see, if you want to build a product for billions of lives, what can be the possible problems? Because at the end of the day, whatever the products you are developing through the AI-based approach, that is playing a role of catalyst. You can say it can help you in making reduction in cost and all those things. But doctors are the ultimate decision makers. So you have to convince doctors that whatever the technologies, whatever the methods, or whatever the procedures you are using, that is completely non-invasive to human body. So due to that, that is not an easy task to convince doctors, because whenever you will go, you may download dataset from Kaggle, you may download dataset from GitHub, and you can build your own model that may work. But you see the practical scenario, because whenever you are developing products for the mass level, practical scenario, you have to deal with in vivo data. And in vivo data, you see, it's a quite challenging task, because you see there will be the interference of stray lights with the original signal, and that remains in a convoluted format. So the accuracy level, in case of, at least for the healthcare domain, it becomes very, very difficult to achieve that type of the higher accuracy in case of the in vivo data. So whenever, if you are targeting for the product development, you have to tie up with hospitals, you have to onboard one doctor as your mentor. So that type of collaborations becomes not an easy task, because as I repeat, you have to convince doctor that whatever the methodologies you are developing, that should be completely non-invasive to human body. And along with that, as I mentioned, that you see nowadays there are a lot of open challenges that are available from the Bill Gates Foundation, United Nations, and from our India, DBT and DST. But you see, the government can give you the seed funding, angel investors and incubation centers can give you the seed fundings. And Indian currency, it is up to 25 lakh to 50 lakh rupees. But if your prototype gets success and you want to scale up from the billions of lives, and you want to finding out your proper go-to-market strategy, then VC's role, I mean, venture capitalist role, is going to play a very crucial role. And Indian currency, they fund up to 3 crore to 5 crore. So basically now, you have to find out, first of all, that who can be your possible users. That becomes very, very important factor. For example, in case of the healthcare domain, if we talk about that, the possible users can be doctors, hospitals, patients. So that thing you have to find out that whenever you are coming up with a new product, who can be the possible users. And definitely the influencers in generally domain-wise influencers varies. For example, if you see the current scenario of the value-based healthcare in United States or Canada, you can see that there are billionaires who are basically by profession physician, but they are basically mentoring several startups for developing the lot of optimum healthcare solutions. So they plays a lot of crucial roles in as a formation form of the influencers. And if you look at the developed countries, and obviously you have to spot out who can be the possible buyer sponsors and partners. And definitely, what do we need research? That is very, very important. That what are the existing technologies there or existing solutions and there, and in which area you can do the better from the existing solutions or technologies, and how you can going to create impact on bottom of pyramid. So you see nowadays, if you are getting success, that's fine, but there are a lot of frictions are also there. So you have to spot out that as well. Now, in terms of the frictions or barrier, you have to be quite aware of the rules regulations, because you see rules regulation varies from countries to countries, several states. Now, for example, if you see that nowadays a lot of students come up with a lot of awesome solutions in terms of the developments with several solution developments with drones. But you see from government of India, there are several restrictions on the large scale deployment of drones. So that may protect you from the development of from the deployment of drones for the mass level. So there are a lot of several frictions and challenges are there. That thing you have to keep it in your mind whenever you are planning of certain innovative solutions. You are planning of launching companies on the base of that. Now, that is one part, and obviously the financial risk factor is always there, because you see you may run out of funding. So those type of things you have to very careful, and that's the reason you require to onboard a mentor that is very important, who has that type of experiences. And definitely execution risks and limiting factors are always there, because you see whenever you are developing for example, if you're developing a software-based products, it can be smartphone-based cancer detection solution, it can be smartphone-based crop disease prediction solutions. So that type of things, whether it is healthcare, agriculture, or any other domain, you see there are always the execution risk factors are there, because you see whenever you are developing a software product, it goes under the alpha testing phase and beta testing phase. Now you may see that your product is doing good in alpha testing phase, it may fail miserably in beta testing phase. So that type of factors are there, and you see in case of especially in the software domain, you may face the software glitches. Sometimes it may not be your fault, it may not be the fault of developers. Sometimes very unfortunate cases happens due to once or out of 100 products, due to 1 or 2 software glitches, you may face a lot of difficulties. You may have to again go back and repeat the same procedure. So that type of things happen, and these are the part of the journey of innovations. So look at this particular plot, that is the plot of problem canvas. Now, you see in the problem canvas, it's the second stage. First of all, we have seen the resource mapping. Now we are seeing the problem canvas. If you see the techniques, whatever we are following, for example, sensors, AI crowdsourcing. So, and you see the problems like greenhouses, crop predictions, farmer finances, weather stations. So this has been the problem canvas has been designed, keeping the mind that we are deploying AI for the agricultural domain. Now map the same problem in case of the healthcare domain. Do the brainstorming. If you do the brainstorming, you will be able to understand it in a proper manner. So for example, if you're mapping the same thing in case of the healthcare domain, so for example, pick up a theme like early stage detection of the cancer. Now, if you detect that, if you pick up that particular theme, then what can be the possible problems? So first of all, you see whatever the industry gold standard is there, biopsy, if you consider that. So along with the biopsy, what can be the possible problems you see? In biopsy, you see the accuracy level is 65 to 70%. That is the one problem. Second problem is that it takes 2 weeks time to come up with the report. So that is a lengthy procedure. That is another problem. And obviously, being a person from the developing country, we have the more than 96% people under the bottom of pyramid category. They do not have enough money to pay tax. So that is another reason. That's the financial crisis. So if we jot down those problems here, now let's see how we can come up with a solution canvas. So if you see the constant, given the cost, time, and impact, you see whenever if you are getting government grants or if you are getting the funding from the angel investors, you see you will not get the full fund once at a time. There will be you will get the fund from the I mean segment wise. Okay, you may so for a 6-month period of time or for a 1-month period of time, for a 1-year period of time, you have to report whatever the progress you have made, whatever the impactful solutions you have made, and how you have utilized that particular funding or grant or financial resources. So according to that, what are the scenarios you are keeping your potential contributions? So this has been designed keeping the digital tech in agriculture in mind. For example, greenhouses with respect to sensors, greenhouses AI, greenhouses crowd steering, crop predictions, sensors. Now, if we map the same thing like I discussed 1 minute ago, that if we want to plan it for the healthcare domain, now if we pick up the theme like cancer, so what can be the possible solutions you can contribute there? Now, if you can develop the AI-based solution for the cancer, for example, oral cancer detection purpose or skin cancer detection purpose, then what are the benefits you can generate? First of all, what your AI-based solutions from the smartphone can generate report within 2 minutes, where biopsy is taking a couple of weeks of time. It can achieve the accuracy level nearby 95%. Nowadays, if you can develop the if you done the data modeling properly. Third one, obviously, whatever the solutions you will develop, that will reduce the overall the product development. I mean, because that is a software-based platform. So if you give them the subscription basis charge as a software as a service charge, so you can charge it for the 100 rupees per scan or 10 rupees per scan. Still, it is thousands times cheaper than the biopsy. So that can be the possible solution scenario. Now, if we look at the time and cost, this particular figure, that finding plot, that is very, very important. That is where our philosophy is quite clear, because whenever we are solving a particular problem, if we are not clear from our mind, that is not going to work at all. So if we look for a given funding and over the prescribed time, if you look at this particular curve, you will be able to understand that where currently we are lying where currently and where we can actually can potentially contribute, and how we can wrap up the ongoing project within a period of time, and how we are going to create impact on those bottom of pyramid area. So this I would request to all of you to kindly take a snap of this particular slide, or I will share with the organizers, because Helmer, these 9 questions from the Helmers is very, very important. Like in science, we worship Einstein. In case of the technology domain, we worship Helmer, because one of his prominent applications and inventions we all use in our daily life, that is LCD, and he's one of the highest number of the patent holders, and one of the most promising, one of the most eminent technologists. So basically, if you see the 9 questions he has highlighted, 9 meaningful questions, that what are you trying to do and articulate objectives without jargon, using jargon, that's very, very important. Secondly, how is it done today? What are the limits of the current practice? So like we were discussing a few minutes back, what's new in your approach, and why do you think that is going to be successful? Who cares? That is very, very important. Then if you are successful, what type of differences you are going to make? What are the risks and payoffs, and how much will it cost? Then how long will it take? And finally, what are the midterm and final exams to check for success? Like I was discussing, that if you are developing a software-based product, there will be alpha testing phase and beta testing phase will be there. So this 9 question arised by Helmer becomes very, very important on the journey of your innovations. So this is overall the lean canvas: problems, possible solutions, key matrices. We will discuss about the unique value propositions or the customer segment, and definitely the cost structures and revenue streams. So let's dive in. Now I'm going from the philosophy part has been completed. Now I'm going towards the science. So we know that from our basic knowledge of physics or engineering physics, those who are from the engineering background, from the engineering physics background, that there are 2 types of this spectroscopy: elastic scattering spectroscopy and inelastic scattering spectroscopy. Now, see, people from the biochemistry background or biologist who basically more relying on the inelastic scattering spectroscopy to observe the biochemical changes happening in our human body through the Raman spectroscopy, fluorescence spectroscopy. Now, you see, from the people from the engineering background or physics background, they are more relying on the morphological changes of the human body. It can be the changes of the refractive index fluctuations, because you see, whenever disease progresses like cancer, there is a change of the nuclear cytoplasm ratio, and due to that, the broken collagen fiber happens, and that happens in a very submicron level changes due to some that causes some submicron level changes, which is not being possible to detect through biopsy. So that's the reason you require to deploy the computerized algorithms like AI to pinpoint those changes, because you see the final, if your disease is in a final stage, all those changes will be clearly visible. But early detection is very, very important. If you can detect in early stages, you can save many lives. So that was the basic concept. Now you see our human body has the self-similar structures. We call them as fractals. So basically, if you see that particular paper in 2006, they have utilized the Brown approximation-based approach for this, for defining this statistical self-similarity. So multifractal resolution analysis is going to play a very, very crucial role here. And we will see some of those developments done by our team along with by hybridizing the MFDFA or multifractal detailed fluctuation analysis along with machine learning algorithms. So you see, as I was saying that, for example, the human body exhibits the self-similarity because human tissues have the self-similar structures. Now you see that the two parameters we are going to discuss here, one will be the Hurst exponent, capital H, because this is a measurement of the correlation. The value lies between 0 to 1. And another one will be the singularity spectrum width, because we have used these particular two parameters as a part of the feature extraction purpose. So you see, this is one of those very, very basic concepts what we have used here. So for example, we all know that whenever you are dealing with images are nothing but a matrix, you see. And whenever you are dealing with the computerized programming over the matrix, we are basically dealing with the nested for loops. Now you see, in machine learning algorithm, it is not only about getting the higher accuracy, but you have to reduce the time complexity as well. Time complexity plays a very, very pivotal role out there. So it is an era of the edge devices, right? Because we all know that there is so much of the pressure on the cloud, we are going to experience latencies. So you always want to have some sort of solutions from your smartphone-based approach. And if you want to deploy certain solutions from the smartphone-based approach, you have to use the very tricky algorithms which has the lower time complexity. So if you see, this is the 2D image. So this is in a matrix format. Now, if whenever you are going by the nested for loop, for example, if we consider that n by n image is there, and if you are dealing with this type of for loop based algorithms, then what will be the order of complexity? It will go by order of n square. So what about deploying the vectorization concept there by unfolding the image in either in horizontal direction or from the vertical direction? Then what will happen if you unfold the image? For example, in my first row I have ABC, second row in DEF. If I unfold them, if I vectorize them, then what will happen? In a column wise it will be ABCDEF, or row wise it will be ABCDEF. So what is the benefit of that? The benefit is that you are reducing the time complexity from order of n squared to order of n. And that is going to play a very, very major crucial role in terms of the era of edge computing. So that is the thing has been done here. We have, first of all, we have unfolded the image in a one-dimensional direction. And then what we have done the Fourier pre-processing. That is very, very important. As I have mentioned, you may remember that while dealing with the in vivo data, because in lab, you may do in vitro experiments, because you are in optics lab, you do the dark room experiments, you capture data, there will be no interference of external noises. But when a real world scenario, you are taking snap from your smartphone based camera, or for example, any other devices, where you are capturing the in vivo data, what will happen then? Unwanted signal, external noises, stray lights will be in a convoluted format with the original signal that will contaminate the original signal. And due to that, it in a spatial domain, it will be very, very impossible to reduce that particular noise. And from our basic knowledge of engineering, we all know that if we do the according to the convolution theorem, from spatial domain, if we go to the frequency domain, so what happens that the signal and noise will be in a multiplicative format. So it becomes easier for you if you do the Fourier pre-processing. It becomes quite easier for you to remove that influence of that particular noise. So that is how we have developed, and we have seen that in the while doing the Fourier analysis, that there are multiple slopes are there. If you look at this particular figure, the multiple slopes are there. So due to that, the existence of the multifractality is there. So in the next cases, this is how the overall the mathematical formulation goes for the multifractality. We remove mean from the original data, then we segment the data, because if there is s number of the segments, we get the ns number of the total number of the segments are there. Then we calculate the local fluctuations, and after calculating local fluctuation, if you see that if you are considering the order of movement q for this for each scale, total scale s, then if you can see that if q of s is proportional to s to the power hq, where the hq is your Haas exponent, and from there you can easily calculate the scaling exponent like tau of q equals to q into hq minus 1, and after doing the derivative of tau of q, you can find the alpha, that is the singularity spectrum width, which is going to play a very crucial role in our analysis. So this is, if you see the profile fluctuation and a local polynomial fit, and after doing that, how we have extracted the degenerate fluctuation, and most importantly, the lnfqs versus lns, this particular plot, if you see, we have considered the order of movement from -6 to +6. So if you look at them, those lines are not parallel to each other. That is the very strong significance of the multifractality, because if it is a monofractal data, then all lines would have been parallel to each other. But due to multifractality, they are not parallel to each other. So as there is the existence of the multifractality, now if you see these three plots, A, B, C, plot number B you can omit, because you see, from our basic knowledge of machine learning, we know that whenever you are going for the feature extraction purpose, all those features should be unique and independent of each other. Then they are going to play a very crucial role out there. So figure B is dependent upon figure A, because as we have seen by the formula that tau of q equals to q into hq minus 1. So at least if we follow the figure A and figure C, that would be good enough for understanding the concept. Now look, if you see the figure A, first of all, for example, grade 1, there is a value you can observe that 0.53. For the grade 3, the value is 0.44. Now you see, grade 3 is the final stage of cancer, and grade 1 is the early stage of cancer. So you can see from the early stage to final stage, there is a reduction of the correlation you can observe. That means whenever disease progresses, there is a chances of reduction in correlation among the human tissues. But if you look at the figure C, the value has increased from grade 1 to grade 3. For example, in case of grade 1, it is 0.69, and grade 3 is 0.89. Grade 3 is the final stage of cancer. So what does it actually signify, this particular figure? This actually the singularity spectrum, strength of singularities spectrum width. Okay, so that gives you the idea about that the tissue surface heterogeneity increases due to broken collagen fiber. So due to the progress of diseases, one thing we have observed, reduction of the correlation among the tissues, and from the singularity spectrum width picture, we can understand that it actually enhances this surface heterogeneity. So due to that, we can see that there are certain chances that we can correlate, because you see, we may do numerous number of the analysis, but at the end of the day, we have to interpret. So we can see this particular feature extraction approach, we can actually analyze what is happening in the human body. But from a single sample, you can't make any judgment. We have to do the analysis for the multiple samples. So this was the overall scenario, initial level scenario, that from the in vitro samples, what we got the idea that grade 1 to grade 3, we are seeing there is a decreasing trend. Grade 1 to grade 3 for the singularity spectrum width, there is an increasing trend. But you see there are overlappings from the standard deviation value plus minus, you see there are overlappings. So you can't classify them, but at least you can see there is a trend is there. So that means you have to deploy machine learning for the classification purpose. So if you see, this is the overall schematic, what the pathways we have followed up so far. And this is the basically our experimental setup. So while I was the student in Indian Institute of Science Education Research, Kolkata, in the lab of Professor Nirmal Logos, we have done the in vitro experiment. So basically, the concept is very simple. Those who have gone through the digital image processing or computer vision, or even from the people from the physics background, they know it very well. So whenever we are shining light and light is hitting the target, so the target will absorb some portion of the light, and other portion will be reflected back. That we call them backscattered spectra. So from the spectrometer, we capture that light, and that particular light encodes the hidden patterns of the target. So that type of phenomena, you can see a lot of applications has been developed by using this type of scattering properties has been explored in a humongous way by the MIT Media Lab. If you see, they have developed seeing through the fog, seeing through the fires, this type of applications they have developed. But in our case, what we have done, we know that whenever, for example, if somebody has a skin cancer or oral cancer, so what we have done, we know that particular infected lesions, okay, if we can shine light there, so what will happen, that target, for example, protein and lipid part of our human body can absorb this certain portion of the light, and certain portion of the light will be reflected back. So that particular portion we can capture through the spectrometer. So that particular information is whether that particular tissue cell has the abnormality or not. If we can analyze that spectra, we will be able to pinpoint out. So this is how we have prepared while dealing with the in vitro samples, this is how we have prepared the overall samples, and what are the age demographics of all details are there. So in general, in a nutshell, we have seen that the recorded intensity, which has been normalized, obviously, then detended fluctuations, then you see whenever, even for the -4 to +4 level of the order of moment scale, you can see there are several fluctuations. Their lines are not parallel to each other. And then again, if you see we have computed this for the single sample Hus exponent value and the width of singularity spectrum. Now, if we go back to this particular table, so from healthy is a normal tissue, grade 1, grade 2 is the early stage cancerous tissue, and grade 3 is the final stage of cancer. So if you look around them, you will be able to see from normal to grade 3, there is a reduction in the correlation level. Okay, and from the singularity spectrum width, if you see, there's an increment in the tissue surface heterogeneity, because the value of the singularity spectrum width is increasing, whereas you can see Hus exponent value is decreasing. So what of the feature extraction tool we are choosing, that is being capable of analyzing what is happening in the human body, but they are not the classifiers, because from the standard deviation value, you can see there are overlappings. So they are not the classifiers. So that's the reason what we have done. We have actually, first of all, we have tried out with several machine learning algorithms out there. So among them, I'm just showcasing here 2 samples result. One is from the MFDFA support vector hybridized approach. Another is the MFDFA hidden Markov model hybridized approach. So in the first case, let's see what we can observe there. So basically, once you can see that if you look at the diagonally, first of all, if you see the first case, this is the normal case. So algorithm is being able to detect the healthy tissues 98.5% correctly and 1.5% wrongly as grade 1. Whereas if you see the grade 1 case, the current algorithm can detect the grade 1 57.14% correctly, whereas 14.29% wrongly as a normal tissues and 28.57% wrongly as a grade 2 tissues. If you look at the grade 2 cases, that 55% it can correctly identify as a grade 2, wrongly identify 10% as a healthy, and wrongly identify grade 1 as a 30%. Whereas in case of the grade 3 cases, it can easily identify all the grade tissues with 100% accuracy. Now you see that the main important observation from here is that healthy and grade 3, it can identify with a good accuracy. Very good accuracy. But when the grade 1 and grade 2, which is a major challenge, because this is at the early stage samples, the algorithm is failing miserably. It is not giving you the good accuracy. So that means that MFDFA support vector machine combinations is not doing well for the early stage detection, whereas change is happening very in a submicron level, like even the biopsy is giving the poor accuracy. And that is the major challenge, to detect the disease in a submicron level. And along with that, the effect of noise is there. You can't remove the system 100% noise free, because you see you are dealing with the in vivo data. So due to that, you all know from the highly noisy system, it is always better to go for the Bayesian model. Like you all know that hidden Markov model is one of the dynamic Bayesian model. So can hidden Markov model help us in that particular manner? Because you see, we are not biased with any method or technologies. We have tried out several ample combinations, and we have found out that the MFDP hidden Markov model is giving us the optimum result. So this is the overall architecture what we have followed for the development of our algorithms. So now you see, here you can see that healthy has been detected 100% correctly. For the grade 1, 85.45% detected correctly, whereas 14.54% detected wrongly as grade 2. In case of the grade 2, you see 78.57% has been detected correctly, grade 2, whereas the grade 2 has been predicted wrongly as grade 1, 21.43%, and grade 3, you see 100% has been detected correctly. So we see that there is a significant improvement in terms of the early detection cases. So that was the major challenge, and we are not doing bad at all. And now we will see one case we have seen for the early stage cancer detection purpose, that where you require the classifiers, you require the machine learning algorithms, because MFDFA was not able to classify them. They are showing certain significant certain significance inferences what is happening in our human body, but are not being able to classify. Now we will see another example. In our last case, we have seen the multi-class classification problem. Here we will observe the binary classification example. For example, probing depth resolved multifractality in human retina from the optical coherences. So basically, you see there are several diseases for the vision loss. So we are considering here the age-related diabetic macular edema. So these are the various retinal layer informations is there. So mind it, I mean, this work has been done in a collaboration with the L.B. Prasad Eye Institute, Hyderabad, and the earlier work has been done in the collaborations with the JSBM Hospital, Kanpur. So now you see, this is also in vivo data. We have deployed the same approach by deploying the multifactorial dependent fluctuation analysis for extracting the all those fractal parameters. And this particular result is showing one particular layer information, that is the outer plexiform layer. And if you see, again, if you see the observed DME means the diabetic retinopathy, that means the disease affected. So again, you see in case of the Haas exponent, the value is decreasing. That means from healthy to disease cases, the correlation level among tissues are decreasing. But from the singularity spectrum with figure, if you look figure number B, again, you can see that the value is increasing from healthy to disease cases, because the tissue surface heterogeneity increases due to broken collagen fiber. So if we look around this for example, healthy and AMD. AMD means age-related macular degeneration, and for the sigma cases. So in each cases, you see NFL layer or GCL layer or IPL layer or OPL layer or OLN layer or choroid layer. In every cases, with respect to healthy to AMD, you can see that there is a reduction of the correlation. But from the healthy to AMD, where there is an increment of the tissue surface heterogeneity from the sigma value, which actually signifies it. So we can see that now, even if you look at the plus minus standard deviation cases, so there are not any overlapping. In earlier cases, we have found there are overlapping, but here you can see there is not overlapping. So we don't have the much samples, much bigger samples, but at least we have seen that MFDFA can also play a good role of being a classifier, but actually it is not a classifier. It is a very strong nonlinear dynamics tool which can be deployed for the dimensionality reduction purpose or feature extraction purpose, but it is not a classifier at all. But in some cases, it can also play a very potential role of a classifier. So first example we have seen for the multi-class classification cases, where actually we required machine learning algorithms to club with them with the MFDFA of a strong, which is a strong nonlinear dynamics tools, and we have developed the, we have resolved the classification problem in one cases, which was a multi-class classification problem, and here you see it is a binary classification problem, and we have done it with the MFDFA. We do not even require machine learning here. So this was the publications, actually, Journal of Biomedical Optics. In mostly the results has been covered from our publications from Journal of Biomedical Optics in 2016 and 2017. So basically, and few of those SPI conference proceedings are there also. So these now we will see the impact of the bottom-up pyramid which we are creating. So that is very, very important. That as I mentioned, that we're being a part of the developing country, it becomes very, very easy. Very, very difficult to pinpoint this type of and address this type of problems and generating impact on those areas. So basically, pain-free early stage cancer diagnosis and low-cost portable device, generating report within a few minutes where biopsy takes several weeks of time, automatic solution and highly efficient. And this is the overall, our developed the oral cancer solutions. If you can see the figure from the app. And now, as I was mentioning during our discussions of the philosophy stage, that I will mention about the unique selling proposition. So replacing painful and cost-effective biopsy, 100 times cheaper than biopsy and accuracy greater than 95%, portable, lightweight, and 80 times faster than biopsy. And that is very, very important, that how you are going to develop your business model or overall revenue model. So B2B product, we all know from those who are from at least from the management background, they know that how the B2B product are getting success. So B2B product for ophthalmologists as well as pathologists. So you see, if you are charging rupees 110 to 100 rupees per scan, still it is thousands times cheaper than biopsy. And obviously that we can sell the device once at a time to the doctors. And there are the growth strategies that is very, very important for any revenue model, because you see, this is a work for the mass benefit purpose, and this is a low cost portable device. So if you can so basically, but still it should have a proper sustainable model. So that's the reason it's very, very important. So ongoing clinical trials are important. You can share the revenue with the doctors. And this is the competitive landscape, which is very, very important to show that how your innovation is better than all the existing product in the market. So in terms of low cost accuracy, smart device, data driven and cloud based approach, so we are providing the optimized solution in comparison to our competitors. And we are actually the first research group across the globe who actually deployed AI for the diabetic macular edema detection purpose. That has been highly appreciated in G News, Odisha TV, News World, India NewsX, and all the global news site in 2016. And also the newspapers like The Hindu, Business Standard, Indian Express, and Economic Times has been appreciated our work in a large extent. And obviously for the cancer research purpose, in 2017, it has been highly appreciated by The Hindu, Business Standard, Indian Express, Analytics India magazine. And I am proud to mention that our cancer research has been included in the syllabus of the UPSC IAS, which is one of the most toughest exam in Indian aspect. And we were the first runner-up in 2017 Global Hackathon organized by NASA and MIT. And this is the link where actually basically our AI-based research has got the honorary mention from the government official site, Embassy of Switzerland. So thank you very much. These are my social media handles. You can join me out there. So thank you. Thanks for giving me the opportunity. And before I end, I just want to ask a very funny question to all of you. After this is a serious talk, after all. So this is nothing to do with science or technology. This is just for fun. That what is the difference between a computer vision scientist and a film director? This is just for fun. This is just on a lighter note. I am just asking this question. If anybody want to try it out, that would be a great help. Anybody want to try from the audience? Okay, so let me tell it. Film director says light, camera, action, right? So a computer vision scientist says light, camera, pixel. Okay, thank you very much.
Thank you, Mr. Sabyasachi Mukhopadhyay, for your nice lecture.
Thank you.
So I will request audience, if they are having any questions, they please can do their questions. So I think Mr. Sabyasachi Mukhopadhyay will happy to answer that thing. Audience, if you are having any questions, please. Hello, audience. I think there is anybody is having any questions, please. There's opportunities there. You can do your questions. So this is a very good opportunity to get Mr. Sabyasachi Mukhopadhyay. So I think there is no questions from the audience. So I will just there is one appreciations from the our conference organization committee. So I will just share that appreciations letters to you.
Okay, sure. Thank you. Thank you.
1 minute, just 1 minute. I'll share that screen. Share screen. Okay. So there is some problem, I think. Just 1 minute. 1 minute, just.
Dr. Devashish Chakraborty, kindly try share screen.
Thank you,
Type
Dr.
shares.
Anirudh. Thank you, Dr. Anirudh, for your kind appreciation. Thanks a lot. Thanks a lot, sir. Thanks a lot.
We are
No,
honored.
I am
We are
sharing
honored,
the
Dr.
screen.
Subhasajit Mukhopadhyay. Your nice thought. What a eloquent.
Thank you.
Great, great.
Thanks a lot.
Dr. Chakraborty, any problem? Is there any technical glitches?
I think there is a sharing, there is some issue is coming. It is not sharing properly. So I think that will be, I think it will be communicated to his mail, no? So
Yeah. It will directly go to Dr. Professor Subhasajit Mukhopadhyay's mail. Our token of appreciation, if we can share it, it will be joy for us. Because sir, you should appreciate that virtual conference is much more tougher than a physical conference.
Obviously.
Last almost 3 days, we have faced so many technical issues. In fact, yesterday night, I couldn't enter. Every now and then my connection has been lost.
Yes, sir, I can understand. It's completely your humongous effort. I mean, which actually made this this conference happen. So
Yes.
I mean, hats off to all of you, all the conference organization committee. I mean, it's your humongous effort which actually made this conference happen. We must appreciate that. Technical faults may happen, and I personally do not mind at all. You can email me, no problem. And thanks a lot for inviting me here. It's an honor to, in front of all of you, to share my thoughts. Thank you very much. Thanks a lot.
Thank you, Mr.
So with that, we end our keynote speech 14. The technical sessions 9 and 10 will begin parallelly from 11:45 a.m. Session 9 will be chaired by Professor Dr. Sudipta Roy, Professor CAC, former Dean, Assam University, Dr. Kaushik Dasgupta, Kollani Government Engineering College, and session 10 will be chaired by Professor Shomo Pal, St. Mary's Technical Institute, Barashat, Dr. Prantosh Paul, Raiganj University. Both these sessions will happen in parallel from 11:45. We will be activating both the links. The link 1 is already active for session 9, and link 2 will become active 5 to 10 minutes before the actual time, 11:45 a.m. that is. So you may join early enough. All participants are requested to join ahead of time so that the sessions can happen very smoothly. Thank you, everyone.
Tufan, can you repeat the paper number? Can you repeat the paper number?
Yes, sir. The paper numbers that are present as per the schedule is 34 for session 9, 34, 142, 143, 150, 151, 153. And session 10 is 155, 178, 181, 187, 47, 98, and 131.
Thank you.
Will there be any additions? Sir?
No, thank you.
Good morning, Aniruddha sir. This is Prantosh.
Yes. Good morning, Prantosh.
হ্যাঁ স্যার আই এম যেটা বলছি যে এই লিংকটাই হবে আমাদের সেশনটা না অন্য লিংকে মানে অন্য আইডিতে
অন্য আরেকটা লিংক টু 5-7 মিনিটের মধ্যে লিংক টুটাকে আমরা অ্যাক্টিভেট করব আর আই এম রিকোয়েস্টিং তুফান লিংক
টুটা স্যার এখানে চ্যাট বক্সে পেস্ট করে দিচ্ছি
চ্যাট বক্সে থাকবে তো
হ্যাঁ চ্যাট বক্সে পেস্ট করে দেওয়া হচ্ছে লিংক টু
অলরেডি দিয়ে দিয়েছি স্যার লিংক 2 has been pasted in the chat box আমি লিংক 1 লিংক 2 দুটোই আরেকবার ভালো করে পেস্ট করে দিচ্ছি
ওকে স্যার ঠিক আছে
সো ডক্টর পান্তোষ পাল এন্ড প্রফেসর ডক্টর সৌম্য পাল আপনারা কিন্তু লিংক 2 দিয়ে ঢুকবেন ওকে বাকিরা লিংক 1 এ থাকবেন কাইন্ডলি আমাদের 3 days EIT কনফারেন্স একদম শেষের পর্বে আমাদের মধ্যে উপস্থিত রয়েছেন আমাদের সেক্রেটারি প্রফেসর ডক্টর দেবাশিস দে। উনার সাহায্য ছাড়া আমরা এত বড় একটা অনুষ্ঠান সফলভাবে করতে পারতাম না। আমাদের মধ্যে উপস্থিত আছেন সম্ভবত এখন প্রফেসর ডক্টর জ্যোৎস্না কুমার মণ্ডল, যার সাহচর্য এবং সাহায্য এবং উৎসাহ ছাড়া আমরা এত বড় প্রোগ্রাম কখনোই করে উঠতে পারতাম না। উই আর অনার্ড যে এরকম দুজন প্রফেসর আমাদের সাথে রয়েছেন এবং তাদের সাহায্যে আমরা আজকে আমাদের EIT কনফারেন্সের অন্তিম পর্বে এসে গেছি। আমাদের কিনোট স্পিচ শেষ হয়ে গেছে, আমাদের আর দুটো সেশন আছে। তারপরে সায়েন্স অ্যাসোসিয়েশন অফ বেঙ্গল দ্বারা কিছু বিশিষ্ট মানুষ এবং কিছু মেধাবী ছাত্রকে পুরস্কৃত করা হবে। সেই অনুষ্ঠানটা 2 থেকে 3টে আমাদের কম্পিউটার সোসাইটি অফ ইন্ডিয়ার অফিসে হবে। আমি বলবো যারা পারবেন তারা এলে আমরা বাধিত হব এবং খুব আনন্দিত হব। আমি বলবো একটু কনফারেন্সের ব্যাপারে যারা উপস্থিত আছেন তাদের কাছে আমাদের কনফারেন্সের প্রাণপুরুষ প্রফেসর ডক্টর দেবাশিস দেকে কিছু বলতে বলবো।
Hello. So today in the valedictory session, the best paper will be awarded. So there are 10 sessions so far. So already 8 session is over for last 2 days. So 9 and 10 is due. So I'm requesting all the participants to be there during the valedictory session, and where the awards will be announced and all the feedbacks will be taken from the stakeholders. I hope you will enjoy the valedictory session, which will be starting from 3:30 p.m. onwards. Thank you.
ডক্টর দেবাশিস চক্রবর্তী, যিনি আমাদের সাথে বহুদিন ধরে রয়েছেন, আমাদের এই অনুষ্ঠানে প্রথম থেকে রয়েছেন, আমি উনাকে বলবো কিছু বলার জন্য।
Thank you, sir. So actually, this is a that EIT 2020 is a very nicely. It has been actually last 2 days. This is the 3rd day actually. So these last 3 days nicely we have been arranged, and all the speaker that everybody has given a very emerging topic, which have been very enlightened us. And surely I think that students community or this thing, they will be very much helpful with this their various new emerging technology talks. So thank you very much. And also I will also thanks to the MacOut organization committee also giving me also opportunity to very well. So that way also I am very much thankful, sir. So thank you very much. And also I will I should also mention that that actually that is who are actually involved 100%, like, and they have how they have been made these organizations even in this pandemic situations. So it is a grateful to them, and that is hats off to them. So specifically like Aniruddha Babu, Dr. Debashis De, and everybody. So hats off to them. So they are making it grand success. Actually, it is about to be success though. So thank you very much to all of you for giving us prestigious times for making it successful. Thank you very much.
Thank you, sir. We are honored that Dr. Devdatta Sinha is with us. I request Professor Dr. Devdatta Sinha to say a few words about our EIT 2020 and his experience through this journey.
Well, thank you, Aniruddha, for giving me an opportunity to say something about EIT 2020. Is it 2020 or 2021?
2020.
So I congratulate all the stakeholders, including you, Professor JK, Professor Debashish, and I will be blamed if I fail to name others. So it is a stupendous task that you have complied with, and I hope that in future I was associated with earlier EITs when Devashish, Jana, and Dipti were very much instrumental in those days. So I think the tradition is continuing, and I hope that in future the tradition will continue further. Thank you very much.
Thank you, sir. I have seen that over here, Sumanto Bhattacharya is present. Sumanto? Mr. Arun Lahiri is there. Mr. Arun Lahiri? Sir, kindly say a few words about EIT 2020. Mr. Arun Lahiri, please. Mr. Arun Lahiri, probably he is mute.
So I think Mr. Anand Lahiri's account, this is a separate account. I think this one is only just for viewers.
Yes. It may happen. Yes, that's right. Okay. So almost Tufan, I request support service team to activate link number 2.
So link number 2 has been activated already.
Okay, thank you. And I request all the professors and participants to join in link number 2 because our next evaluation will start very soon.
So session 9, session chairs are requested to take over at 11:45. And participants for session 9, please stay here. Please do not go to the other link. Your session will continue in this session only.